Space exploration has been a hallmark of human innovation and ambition, representing the pinnacle of scientific curiosity and technological achievement. At the heart of this journey into the cosmos stands a monumental achievement: the world's first space station. The creation of this orbiting outpost marked a significant turning point in the history of space exploration, opening up new frontiers for scientific research, international cooperation, and the future of human civilization beyond Earth. This detailed and comprehensive description aims to explore the origins, structure, and technological significance of the first space station, while also highlighting its myriad advantages, benefits, and enduring legacy for space exploration. The first space station, Salyut 1, launched by the Soviet Union on April 19, 1971, marked a bold new chapter in space exploration. Before this historic milestone, space missions had been short-term endeavors, limited to brief periods of time spent in low Earth orbit. Salyut 1 changed that paradigm, offering for the first time a permanent, or at least long-term, habitat where humans could live and work in space. This station was part of the broader Cold War space race between the United States and the Soviet Union, a rivalry that spurred unprecedented advancements in space technology. By the time Salyut 1 was launched, both the United States and the Soviet Union had achieved significant space milestones. The Soviet Union had sent the first satellite, Sputnik, into orbit in 1957, and the first human, Yuri Gagarin, in 1961. The United States, in turn, had put a man on the moon in 1969. While the US focused on lunar exploration, the Soviets shifted their gaze towards sustained human presence in space through orbital stations. They saw space stations as key to expanding human activity in space beyond exploratory missions. Salyut 1 emerged from this context, designed as a platform for long-term space habitation and scientific research. Its creation represented not only a technological feat, but also a triumph of human ambition, offering scientists the chance to study space in ways that were previously unimaginable. The idea of a space station was not new. Visionaries like Konstantin Tsiolkovsky and Hermann Oberth had conceived of such structures decades earlier. Their theoretical models outlined large, rotating stations capable of supporting human life for extended periods. These ideas were grounded in the belief that humanity could one day expand its reach into the cosmos, living and working in space as naturally as we do on Earth. What Salyut 1 represented was the actualization of these dreams. It wasn't a massive rotating wheel in space like those envisioned in early science fiction, but it was a start. More importantly, it demonstrated that space stations were not just theoretical concepts, but practical realities that could shape the future of space exploration. Salyut 1 was an impressive feat of engineering, considering the limitations of technology in the early 1970s. Weighing around 18,425 kilograms and measuring 15.8 meters in length with a maximum diameter of 4.15 meters, the space station was divided into different compartments, including living quarters, control areas, and laboratories for scientific research. The Habitat module provided living and working space for the cosmonauts, equipped with sleeping stations, exercise equipment, and a small galley for preparing food. It also included life support systems to regulate oxygen, temperature, and air pressure within the station. Research laboratories. Salyut 1 was primarily a scientific platform, and a significant portion of its space was devoted to research. It included equipment for astronomical observations, space weather monitoring, and medical experiments designed to study the effects of long-term weightlessness on the human body. Docking port. A vital feature of Salyut 1 was its docking port, which allowed crewed spacecraft to connect with the station. This was critical for the station's operation, as it allowed cosmonauts to travel to and from Earth and resupply the station with essential goods like food, water, and scientific equipment. One of the most groundbreaking aspects of Salyut 1 was its life support system. Keeping humans alive in the vacuum of space for extended periods posed unprecedented challenges. The station had to regulate air pressure, ensure a consistent supply of oxygen, and remove carbon dioxide and other harmful gases from the living environment. Water, food, and waste management were also critical issues. The station's life support system used regenerative technologies, recycling as many resources as possible to ensure sustainability during long missions. This system was the precursor to the much more sophisticated environmental control systems found in modern space stations like the International Space Station, ISS. The limited available space meant that cosmonauts had to be incredibly efficient with their use of resources. However, Salyut 1 demonstrated that it was possible to create a closed-loop life support system capable of sustaining human life for weeks, if not months, in orbit. Salyut 1's mission was not without difficulties. One of the most significant challenges was docking. The first crewed mission to Salyut 1, Soyuz 10, failed to successfully dock with the station. It was only during the second mission, Soyuz 11, that a crew of 3 cosmonauts managed to dock and enter the station. Unfortunately, the mission ended in tragedy when the crew died during re-entry to Earth due to a cabin depressurization. Despite these setbacks, Salyut 1 proved that long-duration space habitation was possible and laid the groundwork for future space stations. It demonstrated that space stations could be more than temporary outposts. They could be places where humans lived, worked, and conducted meaningful scientific research. Salyut 1, while short-lived, served as a platform for numerous scientific experiments and technological advancements. The station's primary purpose was to serve as an orbital laboratory where cosmonauts could study the effects of prolonged weightlessness, conduct medical and biological experiments, and gather data on the behavior of materials in space. One of the most important areas of research aboard Salyut 1 was the study of how the human body adapts to life in space. Prolonged exposure to weightlessness affects muscle atrophy, bone density, cardiovascular health, and psychological well-being. While early missions provided some data on these effects, they were too short to fully understand the long-term implications of space travel. Salyut 1 offered researchers the opportunity to monitor cosmonauts for extended periods, observing how their bodies responded to the stresses of living in microgravity. This research was crucial in shaping the development of exercise protocols, nutritional plans, and medical treatments for astronauts on future missions. The knowledge gained from these studies continues to inform space medicine today. Salyut 1 also contributed to our understanding of space through its astronomical and environmental research. The station was equipped with telescopes and instruments designed to study cosmic radiation, the behavior of the Earth's atmosphere, and solar activity. By observing the Sun and other celestial bodies from space, researchers were able to gather data without the distortion caused by Earth's atmosphere. These studies helped improve our understanding of solar flares, cosmic rays, and the space environment, all of which are critical to future space exploration. This research also had implications for improving satellite technology and communication systems on Earth. Another important area of research aboard Salyut 1 was materials science. The station provided an environment where scientists could study how materials behaved in the unique conditions of space. In microgravity, materials can form in ways that are impossible on Earth, leading to new insights into their properties and potential applications. This research contributed to advancements in manufacturing processes, particularly in the fields of metallurgy and crystal growth. These findings were not only important for space exploration, but also had practical applications in industries on Earth, such as semiconductor manufacturing and aerospace engineering. In conclusion, the world's first space station, Salyut 1, was a monumental achievement that changed the course of space exploration forever. Its contributions laid the groundwork for modern space stations, scientific advancements, and the possibility of future human colonization of space. As we continue to push the boundaries of what's possible, it's important to remember these pioneering milestones that paved the way for humanity's journey into the cosmos. If you enjoyed this deep dive into space history and technology, make sure to hit the subscribe button, like this video, and share your thoughts in the comments below. Stay tuned to TechNation for more exciting content on cutting-edge science and technology.